I'm Charles Wilson, Staff Product Cybersecurity Architect at Torque Robotics. This presentation will cover issue triage. Here's the overall AVCDL training path. If you're taking this training, it's assumed that you've already completed the AVCDL overview training and that you've also completed the requirements taxonomy, security requirements, secure design principles, apply secure design, and threat prioritization trainings. This training will cover issue triage. When cybersecurity analysis is performed on the various elements of a system, the issues that are generated can sometimes be received by development as though a mass of issue documentation has been summarily dumped on their desk. No one wants to be the recipient of 10,000 issues that come from an analysis being performed for the first time. And no one wants to be the recipient of hundreds of issues and have to go through them only to find out that a large number of them are irrelevant or incorrect. What we would like to have are nice, neat separation of those things that we really need to deal with, those things that we need to review, and we don't want to see the ones that aren't relevant. And so this is why the AVCDL analysis processes contain a triage activity. This triage activity, in fact, does divide things into 3 buckets, as illustrated here by these 3 binders. And the hope is that when this triage is done, that we can deal with those things that need to be dealt with immediately. We can defer those things that need to be reviewed further so that they can go to the people who will consider them in a greater context, and that we can dispatch those things which aren't relevant to the element and by extension to development. Let's start by looking at the general triage workflow. If people do think about triage, they tend to do so in a very focused fashion and in relationship to a particular analysis process. The problem with this is that it misses out on the opportunity to have a consistent approach to triage across all of the analysis processes. Of all the domains within the product development realm, cybersecurity tends to be the most resource constrained in terms of people. And so having a single way that triage is approached really helps to make cybersecurity more efficient at what it does. In the same way that we have the threat prioritization process making the handling of issues consistent, it would be helpful to have a single triage activity for every analysis process. But one size doesn't fit all in terms of triage. It's not just that we get issue candidates in that we have cybersecurity and development, and that's a critical aspect. Taking part in this triage activity, determining that some things are going to be rejected and others are going to have to be addressed, forming our triage issues, and producing an analysis report. We have to consider the analysis activity that we're undertaking. Additionally, we can't just either dump everything into the issue tracking system or into the threat prioritization process, because either of those actions would waste a lot of time downstream. Additionally, we don't have a single behavior with respect to the issues we reject. There are 2 distinct categories of analysis that we need to consider. The first of these is implementation analysis that's done once the element has been realized. These are things like static analysis, dynamic analysis, fuzz testing, and penetration testing. We also have to consider that we have design analysis. Design analysis doesn't work with the element itself. It uses a model of the element. Now let's look at the mechanics of performing the triage. When you're performing a triage, it's important to start with the recording document that's going to be used. This may be obvious, but there are many times when people start a triage activity and they'll just kind of start cold. The problem with this is that when you go back to try to deal with the results of this type of approach to triage, you just don't have the information that would be useful in order to deal with the issues. The AVCDL provides a set of templates for many of the activities, and triage is no exception. Common to all of these templates is information about the element that we're talking about, who's doing the activity, when it happened, revisions, reference documents, things like that. And we're not going to go into those here because that's covered in many different places within these trainings and the individual procedures provided within the AVCDL. The thing that we're going to focus on here is the triage determination information. This is a sheet taken from an Excel workbook. This is not to imply that Excel workbooks are the be-all and end-all of how this type of documentation is recorded. So long as you capture all the information that the AVCDL specifies, you're good. The embodiment is up to the organization. For every triage that we do, we care about the issue ID. The reason that we use an issue ID is because it's presumed that the issue is coming to us from another source, and we're not going to paste the issue information here because then we can end up with having the issue not tracing back to a single source. Next, every issue that's triaged receives a determination. This determination is very contextually based depending on the analysis tool being used. For those issues that are going into the threat prioritization process, it may be useful to provide a preliminary severity. The nature of the preliminary severity is going to vary widely, and we'll discuss that in a bit. If you decide to reject a particular issue, you have to say why. Because again, it's not when you do what you should do that requires justification. It's when you decide not to do something when there's an indication that there's an issue present. So, I get an issue, I'm not going to deal with it, and this is the reason why. That reason always needs to be there. And finally, there are notes, which vary depending on the type of the analysis being used. Now let's look at the determination itself. And when we think about the determination of the triage, we're going to use 3 buckets to classify the issues. The first is that of repair. We're going to assign this when it's clear that the issue requires mitigation. These issues come from things like a dynamic analysis test which terminates on error. Similarly, a fuzz test that catastrophically falls over. In the design realm, it's things like an attack surface analysis that shows that there's a port that's being presented which has no functional justification. And so these are things which are obviously in need of being corrected. There's no necessity for these to go through the threat prioritization process. These issues should go directly into the issue tracking system to be addressed. The second bucket that we have is that of review. These are issues which are valid but aren't obviously critical. What we're going to do with these is send them through the threat prioritization process to determine whether they need to be acted upon. Finally, we may determine that the issue is invalid within the context that's been presented by the analysis. And so, we're going to reject it. The question becomes, how do we reject an issue? As it turns out, issue rejection manifests itself in 2 distinct ways, depending on whether we're looking at a design analysis or an implementation analysis. When we're talking about design analysis and we reject an issue, what we're fundamentally saying is that the element model is incomplete and the issue would not be manifest if the model took into consideration other information that it doesn't presently. And so, when we reject a design analysis issue, we need to go back to the model and update it. This also has the implication that we're going to rerun the analysis once the model has been updated to verify that the issue doesn't present itself again. In the case of implementation analysis, when we reject an issue, we're not making a statement about the element, but rather the tooling of the analysis itself. This is generally the result of a false positive coming from the tooling. We need to go back and either adjust the configuration of the tooling or any related tests that are being facilitated by the tooling. In some cases, this can be accomplished by adding tooling-specific annotations to the code. In others, the tool settings themselves may be changed to omit specific checks. And again, just as with issues that occur in the design analysis, with the implementation analysis, we're going to rerun the analysis to verify that the issues do not manifest. For issues that have been determined to need review, a preliminary severity may be assigned. Keep in mind that this is an optional step. It should only be done in cases where there's an issue of importance. If you're dealing with a run-of-the-mill issue, then assignment of a preliminary severity may be skipped. Note that the AVCDL provided templates do not include a particular list of values that should be used for the preliminary severity. The reason for this is easy to illustrate. Consider the following. Here's the CVSS score. It has a range from 0 to 10. Alternately, we can look at the CVSS rating. Its values are low, medium, high, and critical. We've added a true 0 or none here because that makes things easier when you're dealing with automation. These aren't the only choices for severity, also known as rank. If we look at what's specified in ISO SAE 21434, for example, we have very low, low, medium, and high. Unlike the CVSS ratings, the ISO SAE 21434 ratings don't specify what values should align to. The AVCDL chooses to align them to the CVSS rating ranges. Your organization might use something completely different. You might have a 3-valued severity of low, medium, and high, or simply a bug bar with values bad and not bad. These are very organizationally dependent things. And so, this is provided only as an example of what may be used. Additionally, don't presume that this information is going to be consistent from organization to organization. This brings us to the portion of this activity that everyone looks forward to, and that is the report generation. Now, some people would argue that, well, we have this list of triage issues, they can just read that. This misses the point completely. This is a human-readable document. It's also intended to be a document of record that's readily accessible in the document management system for review and for audit. And so it needs to be more than just a spreadsheet that you sift through in order to find information. This is a snapshot in time. Ideally, it's stored in the DMS as a PDF so that we don't need anything special to read it. As a PDF, it's not editable in the traditional sense. Some would argue that it's just replicating things, it's difficult to do, it's a lot of cut and pasting. If you're thinking this, you should consider automation. If the issues are going through the system as JSON-encoded Serif files, then creating a PDF is straightforward, as the Python language has the capability to directly read JSON files. It can also generate PDFs, so there's no necessity of doing anything special. It's a step that you build once and use forever. You can take the Serif file and generate a report or regenerate it as necessary. And since the AVCDL recommends a common Serif structure, you can use the automation across all analysis activities. As a courtesy to the consumers of the report, it's recommended that you group the issues by the categories that they've been assigned, and not just intersperse them, as this makes more work for the people consuming the report. That covers the generalized approach to analysis issue triage. Now let's review some important points that we've covered in this training. First and foremost, when you're performing triage, always involve development. The analysis that cybersecurity does has direct impact on development, and so development needs to be a participant in the process of determining whether the identified issues are valid and in need of further review. Next, address the obvious issues first, whether these are going to be rejected or they need to be repaired. The reason for this is that you develop momentum. It's easier to set aside something which you're not sure about and deal with that later. You're making the pile smaller faster. When it's appropriate, assign a preliminary severity to those issues which are going into the threat prioritization process for further review. And finally, create the human-readable report for review and for audit purposes. The AVCDL provides a large number of related documents available in its GitHub repository. These provide further information and more in-depth references to the area of triage. So let's cover some of those now. First, we have the threat prioritization plan, which is what the triage activity feeds into when issues require further review. The next are the Attack Surface Analysis Report and the Threat Modeling Report. These cover the area of design analysis. To go along with these are the Attack Surface Analysis Triage Procedure and the Threat Modeling Triage Procedure, which detail how triage specifically works for those two processes. In the area of implementation analysis, we have the Fuzz Testing Report, Static Analysis Report, Dynamic Analysis Report, and Penetration Testing Report process documents. At the time of this recording, only the Dynamic Analysis Triage Procedure is available. As time progresses, the triage procedures for the other implementation processes will be added to the repository. All AVCDL materials, both in source and distribution forms, are available on our GitHub site, as shown here. Because of the size of the repository, it's recommended that you either clone the repository or download a zip archive of it if you're not familiar with using Git. Instructions for downloading a zip archive are linked to on the repository's front page. Videos covering various aspects of the AVCDL are available on our YouTube channel, as shown here. It's important to note that all AVCDL materials, except for the introductory blog posts, are intended for product cybersecurity engineering practitioners. Here are the references to the source material used in the creation of this presentation. They'll also be included in the video description. Additionally, this presentation's source material will be provided on the AVCDL GitHub repository.